Thank you to all the speakers this morning for their talks. And we heard very sort of differing sort of aspects of physical AI. But, you know, we've been hearing about all of this over the last 2 years, robots at CES, humanoid robots, and now we're talking about agents doing lots of stuff. But maybe I'm going to come to you, Mr. Mamoru Nakano. I think you talked about making AI and high-performance computing as open and accessible as possible. Tenstorrent has been very vocal about rethinking AI compute architecture. When we think of it in terms of the context of physical AI, what fundamentally needs to change in the industry's approach as we move from cloud AI to physical AI at the edge? And I know that last slide you showed was around the token economics, which is basically cheaper tokens. But I think it's a different concept altogether for what you need to do for physical AI at the edge, isn't it?
Not so much different, but
okay.
The edge computing must be very cheap, right? Yeah. Must be very cheap.
Okay.
Because everybody wanted to make use of the AI, so cost must be cheap. So it must be if it is $100 or $1,000 and more. So we cannot make use of the technology. So that is the main reason. So the Jim and we believe that AI need to be low cost and very fast and very easily to use, right?
And is that a result of open architecture, I guess?
Yeah.
And RISC-V. Can you explain a little bit about that? Explain sort of how you enable that open architecture.
First of all, make it open as far as possible. Even an IP is itself a very confidential and very important thing, but try to make the open as far as possible. Like a RISC-V, instructions is very is open, and the SDKs are open for me. So you can make use of the SDK as soon as possible.
Okay. Sudipto, I think you talked about deployable, scalable robots and taking embedded intelligence to autonomy. When you think about it, as physical AI systems move from concept to deployment, you're at the sort of the end where people are doing things, making things, manufacturing things. So what are customers doing now, demanding from the manufacturing and platform side that wasn't a priority before as a result of this increase in physical AI? You showed some of the things around humanoids, but maybe just some examples of things you've seen, especially with what you're doing.
I'll without taking names, I'll give an example
Yes.
of a problem statement that a customer gave us, and it was specifically around the arm. And when you think of an arm, right, it's a very complex system. So you can start with the palm, right? The number of joints you have in not our fingers, but what the robot needs to have to pick something up, to be able to apply the exact pressure that you need. Like think of just a pair of hands working in a factory assembly line where they're assembling parts, right? So the number of small motors that you need to just move the palm and the level of intelligence that you need so that they're all moving in cohesion is non-trivial. This particular customer was trying to see how they can control all of the brushless DC motors in the palm using one microcontroller, right? And eventually, as we discussed more and more with them, it came to, it needs to be low power, small, have a lot of IOs, which can drive high voltage signal. So as we looked across our portfolio, we said, what, this is what is the closest to what you need. And we'll add a few more features. And from there, we'll evolve into something that they can really put I mean, size is also a big aspect when you think of an arm, right? So that was just a palm. And then you go to the joints, right? And then you go to from the elbow to this joint, and the requirement of not just processing, but the level of mixed real-world signals that it has to deal with is something that we have not thought of. So these are valuable inputs which we are getting, where we are adding feature set not just for compute and memory, but also interconnect, motor drives, size, packaging, the physical XYZ of the solution. So that's why when I think of a robot, the first thing that comes to my mind is a hand, because that's the one that's doing most of the actions, right?
Yeah.
The legs will take it from point A to point B, but once it's there, and you're asking robot, make me a cup of coffee, it's really the hands that are, doing a lot of stuff.
Are you seeing a demand for that that sort of hand-type movement and things like that? I mean, people doing things like that, or is that mostly in sort of industrial environments at the moment?
This particular customer I'm talking about wants to build a humanoid, right?
But in industrial, or are you?
No, this is this classic humanoid, which they want to deploy, of course, in the factory floor as well as everywhere else. I do not have an exact example, let's say, of an industrial robot, but I would imagine that once the robots, I mean, the picture that you have, I can see it over there. I think that's close like a KUKA robot. All you see is one appendage which picks things up and drops things down.
Behind you.
Right? It's behind me, exactly. Now, from this to this is in itself a transformation, which I'm sure is going to push us in all different directions.
And I think, Gabriel, you mentioned in your presentation you work very closely with MIPS, and I mean, we know the customer, but for a long time. But the stuff you're doing there, I guess, translates quite a lot to the robotics and the physical AI, and maybe at a higher level before we go into that. What do you see are the biggest system architecture challenges developers face when designing autonomous edge platforms that must process and respond to data in real time? And I think that's kind of relevant to translating from what you've been doing in the automotive to the robotics.
Right, so basically, as I mentioned in the presentation, right, most people focus on the computing power.
Yeah.
But when we actually build cities and shopping malls, we often forget the most basic infrastructure, right? We have to build roads. We also have to build expressways and interstates that connects everything together. So basically, what is really challenging architecturally is that we have a lot of customers focusing on making the most powerful accelerators, most powerful NPUs, but they struggle to make data pass through them quickly enough, right? So a lot of time we see our customers end up with a design that what we call data stuffed, right? So this is what we actually do, right? So that's why we start to develop technologies like broadcasting and multicasting, which will allow the NPUs to not always access the memory for the data, right? And cache coherency, that also helps. So I guess the biggest challenge is really to find this right balance between computing power and data movement and scale everything together.
Interesting. How does Arteris see the intersection of, we're talking about open, like RISC-V, the acceleration and the advanced SoC architectures as industry moves towards more agentic and autonomous systems?
Well, RISC-V is really bringing a lot of changes to this environment, right? Because back in the days, we only had to deal with a handful of processors and handful of computing architectures. Now with RISC-V, Tenstorrent, and MIPS, they started to allow our customers, our designers, to make a lot of things that we have never seen before, to be honest.
Yeah.
So this is quite a challenge, right? So, but what we try to do is we try to be as generic as possible, right? So we want to be able to support the standard protocols, and we want to be able to connect with everything that our customers make, regardless of what processors they actually use or what GPUs or NPUs they actually try to use, right? So we try to stick to the standard protocol, which would allow us to connect really with our customers' IP.
Yeah, I mean, you had a very impressive customer list up there. So I think there's a lot of need for that connectivity, which actually, as you said, has been forgotten quite a lot over the conversations, and especially also the analog side, which has been forgotten. So it's quite interesting how Physical AI is bringing all of these conversations back in. Any thoughts on that, Sudipto?
I agree with you. Like, that's my first thought. But let me think of one more example of what you said, right? Like,
yeah.
And the word physical itself kind of helps that definition. Let's talk about sensors, right?
Yeah.
Two things: sensors and connectivity, right? A car or a robot to move inside this room and be able to maneuver all the obstacles that you see, it needs to sense the physical world, right? And that it will sense either through vision, can be ultrasound, can be a very high precision radar, right? But then once you sense it, the information has to travel from the sensing modality, can be a camera, can be speech, to the compute at a very high speed and a reliable speed, right? And that's where you get to decide whether it's Ethernet, it's SerDes, it's something else. It's kind of the problem that he talked about, connectivity, but in a system, right? You have connectivity inside the chip, you have connectivity inside the system, and then you have all the sensing piece of it. So it's, I guess, the way I would kind of echo back what you said, Nitin, is it's not all about digital processing.
Yeah, and I think that was the point of my question.
Right. Eventually, it has to be processed, but
yeah.
to get the information to the processor
Yeah.
and to get the decision back from the processor to the place where it needs to do something about it, there is a lot of innovation that needs to happen in that path.
Any thoughts on that?
Yeah. Well, it's a system problem, right?
Yeah.
It's just not. It's not an independent connect problem. It's not a processor problem. That we all have to work together somehow to figure this out, right? We need the foundries to be able to support the manufacturing of, with the right IOs, right? The analog IPs. We need the processors to do the heavy loading, right? To do the computing, right? We need the interconnects that connects everything. So I think the way we see this is that nobody can do this alone, right? We have to. That's why this partnership is so important, because this allows us to sit together and figure out how we're going to tackle this challenge.
You said something very core to this whole industry. Nobody can do this alone. I interviewed the Minister for the National Science and Technology Council this week, and he talked about how, despite Taiwan's position in the global electronics ecosystem, it does involve a lot of international collaboration, and not just international, but industry. And on that basis, I think, one of the things I think I was going to ask you around what Tenstorrent is doing is around that whole openness for processing architectures, and how is it different to data center training for doing edge AI? And I think, I suppose my question is, agentic AI systems need to think and act in real time under tight power and latency constraints. And how does that challenge make it different from training or inference in the data center?
Technological point of view is, each segment required each, specification and functions. But most important things is the entire ecosystem, as you guys mentioned.
Yeah.
So like open standard ecosystem, and also the standard chiplet system, interface and something like that. So many chips, come into the same die or something. So make use of the many components or partners. That's important things. So you mentioned about real-time things. Okay. So now we are developing a real-time CPU as well. So then it's a technology, but it's standard like a RISC-V uniform instructions is very good, and make it very useful, I think. And also the chiplet is now getting a standardized day. So it's probably every vendor make their own CPU and accelerator, but depend on the same standard. It's we exchanging the technology and make a partnership together. So that's a whole ecosystem. So
I'm going to ask a question which maybe you'll be too concerned to answer. You probably want to ask Jim, but your CEO. But looking ahead, what breakthroughs, whether in hardware, software, or system architecture, and we're talking about the whole software to silicon to software here, what breakthroughs do you believe will define the next phase of physical AI adoption? Put Jim's thinking hat on.
Oh my gosh.
I mean, I'll open it to the floor. I think it's open to everybody, actually.
Yeah, so stacking things like stacking memories, stacking CPUs. So the image sensor with stacking with CPU and accelerator as well. So the intelligent image sensor and so on. So such kind of a new technology makes it happen for the more rich function and reducing the software.
So you're more beyond multi-die, that stacking, like the memory is doing at the moment, like 32 high, and whatever.
Yeah.
Any thoughts? Breakthroughs?
I'll give you some thoughts, and we'll have to wait a little bit for the breakthrough. We are really focused on TOPS per watt.
Yeah.
Right. So we have kind of made this an internal mantra that the next platform that we'll develop, which is really tuned towards delivering physical AI, will have to focus on TOPS per watt, meaning, yes, you can deliver some level of compute, but how much wattage are you consuming, right?
Yeah.
So you'll see GF make announcements, do investments around TOPS per watt. The other thing, and it's kind of a plug, Nitin, but you had an ecosystem question, right?
Yeah.
We quickly realized that for us to offer solutions in the physical AI space, just being a foundry is not going to be enough, right? This is why we have MIPS. This is why we have ARC.
Yeah.
And there are a few other things that we have to do to kind of not try to solve it with one tool, but bring as many tools as we can in the whole ecosystem to provide an optimized solution. And that has to start from software down to transistors, right? It's a combination of all of these things.
You're coming back to a story that I've got to tell. Hope James doesn't mind me taking a bit more time. But when we were doing the ARC journey back in the 90s, one of the things we realized is it was a part of an ecosystem play. So that's where then we were working with tool providers and IP providers and protocol stacks. So we acquired 3 companies. We acquired MetaWare for the tools, the tool chain, which is in Santa Cruz. We acquired V Automation for some of the IP and Precise Software Technologies. And I think that's plays into like what this whole ecosystem story. So it's still going, and I think that's. I'm quite happy that you said it's all about putting more into it and putting the bigger picture. I think we should probably close, but what are your final thoughts? Maybe I'll start with you at the end. What are your final thoughts on sort of making physical AI happen at the edge?
Rapidly changing in the market. So, first of all, please enjoy the new technology, and also we also enjoy the new, technology and also the usage. So, yeah.
Gabriel?
Well, I think it is already happening, right? We already see Tesla driving around by itself. We see robotaxi, but right now it's just like it is still too complex of a system, right? And we are still trying to learn how to deal with it and try to simplify everything and maybe to integrate everything together. So, from Arteris' perspective, we really think that we actually embrace openness and standard, right? So I think there are still a lot of things we can do today. The foundries, they already have 2.5D, 3D stacking of the chip to chip and die to die, right? But in reality, from our perspective, we still see many different protocols that are out there, right? We are not getting, so it makes harder for people to work together.
Yeah, I think you have written in the pages of EE Times quite a lot around open standards for connectivity, chiplets
Big
as well.
fan of
yeah.
EE Times.
But I think you said something quite interesting, simplify and integrate. I think that's key. Yeah. Last thoughts from you, Sudipto.
I'll start with the story and then I'll give my thoughts. I happened to listen to a New York Times podcast, Nitin, and I'll forward to you if you have not listened. It was about a company which has deployed 200, they call it robot, but it's actually, you can speak to it. And the purpose of that is to keep company of people who are extremely lonely. And this interview was of an 85-year-old woman who lives alone and who says that this thing is my best roommate. Now, the reason I go back to the story is I don't think we collectively know what the killer application of physical AI will be, right?
Yeah.
IoT went through that phase, self-driven car. So I think what we need to do, and this is what we are trying to enable as a company, is we need to be open to experiments.
Yeah.
And we need to be able to create an ecosystem that can help make those experiments not very difficult. Because once we have 1,000 experiments, 10 of them will turn out, and some of them will be the killer app that physical AI will survive on.
Well, if there's one industry that does do experimentation in my 4 decades of doing this, I would say this industry is really good at innovating and experimenting. So on that thought, thank you very much to all our panelists. A round of applause for our panelists here.